Good morning, ladies and gentlemen, and welcome to our presentation. First of all, let's thank you all for taking time to watch our presentation video. The purpose of today's presentation is to the analysis by means of size reduction. Let me introduce myself first. My name is Nathut Twandam, and my team are Mr. Nathanon Hasabdi Sunthorn, Mr. Jirawin Pachit Khonburi, Mr. Sahasawat Nagnok, and Mr. Waratman Charan. We are first and second year in major of chemical engineering in the Faculty of Engineering at King Mongkut Institute of Technology Ladkrabang. The topic of our presentation is the analysis formula of size reduction. The reason why we chosen this topic to present to the audience because our group have the opportunity to make size reduction in laboratory. We are aware of many benefits of this method because this method has simple principle and simple method to do it, and it has many available, for example in the pharmacy, in the industrial. So we have divided our presentation into four main parts as follows. First of all, we would like to give you an overview of the theoretical background of principal size reduction. Next, we will focus on experimental size reduction of sugar with the ball mill and part calculation. We will calculate particle size and number of particles of the sugar. And then we will consider result and discussion of variable its effect to the size of particle. Finally, we will deal with conclusion efficacy of the ball mill and implication of size reduction method. Let's now begin with the first part.
I am going to start with the mechanism of size reduction. Size reduction of particles is very important and useful in many chemical and other industries. There are three reasons. First, handling of small particles is easier as compared to big particles. Second, there is an increase in surface area per unit volume. Due to higher surface area will enhance the rate of reaction involving solids. Third, entrapped components are separated and may be available for further reaction. Classifying particles to remove contaminants and allied particles. Size reduction is major unit operation in industries handling particulate solid. The industries like mineral dressing, paint, cement, bauxite, pharmaceutical, as well as black powder. The term size reduction is applied to all the ways in which particles of solids are broken or cut to smaller pieces. Solids are broken in four different ways. First is impact, particle concussion by a single rigid force. Second is attrition, arising from particles scraping against one another or against a rigid surface. Third is shears, produced when the particle is compressed between the edges of two hard surfaces moving tangentially. Fourth is compression, particle disintegration by two rigid forces. The equipment to be used for size reduction is ball mill, which we choose for the experiment. The ball mill is kind of glider used for intermediate or fine gliding. Ball mill is a metal cylinder which rotates about its horizontal axis. The coarse material breaks to fine powder by impact of metal balls. The ball mill glides material by rotating a cylinder with a steel guiding ball, causing the balls to fall back into the cylinder and onto the material to be ground in the picture A and picture B. The rotation is usually between 4 to 20 revolutions per minute, depending upon the diameter of the mill. The larger the diameter, resulting in the slower rotation. If the peripheral speed of the mill is too great, it begins to act like a centrifuge and the balls do not fall back but stay on the perimeter of the mill on the picture C. The point where the mill becomes a centrifuge is called the critical speed, and ball mill usually operate at 70 to 80% of critical speed. The other equipment that we use for size reduction is the shaker and sieve that used together in the part of analysis. They are used to shake a stack of test sieves, which are placed in order. So that material gets sifted through according to particle sizes. In the experiment, we choose sugar to be the independent variable. Last, the equipment for measuring is balance and measuring cylinder. After we know the mechanism of side reduction and how the ball mill working, so we continue to the experiment of project.
First of all, I'm introducing you about the required values in this experiment, that is density and critical speed. I think most people understand the density very well. It is a value that can be calculated from this equation by using the value of mass divided by the volume of sugar. In the part of critical speed, it is the speed in which the ball is thrown at the wall all the time, so it can be calculated from this equation. In addition, for this experiment, we will use the rotation speed, which is lower than the critical speed, at approximately 70 to 80% of critical speed. So, the procedure in this experiment is an important part that I have to talk about then. The procedure is divided into parts, which includes ball milling and site classification. First of all, load 120 small balls into the ball mill, then weigh 200 grams of sugar and put into the ball mill. Set the operating speed of ball mill to be lower than the critical speed. After that, run the ball mill for 10 minutes. For additional information, change the ball into 50 large-sized balls and repeat the step of ball milling. In the part of site classification, arrange a set of standard skins with the smallest mesh at the bottom and the largest one at the top. Then, put the unmilled sugar into the top tray. From this point, put the set of skin into a shaker and shake it for 20 minutes. Lastly, weigh and record the weight of sugar remain in each skin. However, for milled sugar, put the milled sugar obtained from the ball milling section and repeat the step of site classification. For the next topic is finding of experiment.
In the part of findings, this slide shows the findings or results from experiment. We are record the range of sieve tray, weight of sugar, can be calculated mass fraction and cumulative mass analysis from smaller than state size. Next, we can calculate number of particles in the solid mixture from this equation. Next slide, please look at the graph figure 1. From the vertical bar chart, show the different analysis by histogram plotted between mass fraction and the average particles in each site. For example, particle size range 600 to 849 has the highest mass fraction of unmilled values. Next slide, please look at the graph figure 2. From the line chart, show cumulative analysis by plot between cumulative mass fraction smaller than state size and particle size. For example, particle size at the range of 75 to 149. Cumulative mass fraction of T curve has the most similar values. Next is the conclusion of experiment. The higher speed of the batch has more effect of green sugar. Size reduction of sugar by using ball mills make small size in micrometer. Grain with 50 large size make size reduction of sugar more than 120 small size ball. In the next topic, we will show you about implications and applications.
From this slide, I will present about the application of side reduction. For transportation, a particle are reduced the size by side reduction. So in transportation, we will transport a lot of particles. For example, plastic waste in the part of cosmetic. We obtain fine powder in the cosmetic component, which is convenient to use. For chemical industry, sedition is used to increase rate of reaction or absorption of substance, and it can be applied to cement industry, reducing the scale of cement to make it easy to bend. Next, in the past of pharmaceutical advantage of sedition to increase surface area and improve the area of reaction, increase medical effectiveness and keep it in capsule quickly. For mineral identification, sedition is used to reduce the scale of mineral. For mineral detection, and then put it to analyze with analyzer. Advantage of minimizing size for mineral detection. For quick examination and effective mixing, for example, it can be mixed as mineral water. Finally, for food industry, we may use sedition to minimize size of foods. For example, we can bring soybean to minimize size to powder and keep it in packaging. Advantage of reducing size for food industry. Increasing surface area. To increase nutrient absorption. To increase zinc dye inlays. Easy to combine and bend, and simple to load.
We are now approaching the end of our presentation. In conclusion, I would like to briefly summarize the main part our group have covered. In the beginning, we have given you an overview of simple principle working of size reduction. After that, we have told you about method to make size reduction in laboratory and path calculation. We show solution for calculate critical speed and number particle size. We have also given you the particle size of sugar based on the size of ball mill. And finally, we discussed the large ball mill have efficacy for clean the sugar more than the small ball mill. We hope you will find our presentation useful. Thank you for your attention.